Good afternoon. Welcome to the post-lunch slump. Hopefully you guys also enjoyed that really good barbecue. So I'm Melissa. I'm here to talk to you guys about what it takes to move a really old code base, something that probably deploys maybe every 6 months, maybe every 3 months, into something that can deploy very quickly, on demand, on the order of hours to days. So who am I to talk about this? So I am a senior engineering manager now with a company called mParticle. But more specifically, this is something that I've done several times in my career now, taking old, big chunks of code, legacy code, and migrating it over time into something that is digestible, something that can be changed. I first did it in Bing when we initiated the long, arduous road to deploying continuously. We had awful long releases. I'm sure many of you are familiar with parts of the stages where you have six weeks of code, everybody frantically writing the code, and then it gets tossed over the wall and there's 2 weeks of frantic testing. And then in theory, there's a week of integration. And then there's 3 weeks of, well, everything just broke, now what do we do? And then finally, something gets shoved out the door and we start it all again. Madness. What online service can wait 6 months for an update? Certainly not Bing. And so what is exactly continuous delivery? So continuous delivery is the process by which we take some code under source control, we make some changes to it, we do code reviews, we build it, we test it, we iterate on it, and then we release it out into the wild, and we monitor it to see how it's actually performing. This is continuous delivery. Maybe your code deploys automatically every time you make a change, maybe somebody has to push a button. That's the very slight difference between continuous deployment and continuous delivery. I'll try to be very precise with the terminology. But it's very similar either way, right? What we're concerned about here is the ability to deploy at any moment in time. If you can actually deploy every moment in time, that's great, but that's almost a semantic difference in a lot of cases. And so why does this matter? Why is everybody going on and on and on about continuous delivery? When I was in the middle of putting this talk together, my husband came home one day from work. He's an IT program manager at Microsoft, and put this book on my desk. He said, you have to read this. And this book was Accelerate, done by a number of professionals in the field, and it had actual measurable data about why continuous delivery is important and the differences between organizations that perform, that are very high performing and organizations that are very low performing. And they found some really interesting things. Organizations that were high performing, that had very good continuous delivery practices, had a 50% market capitalization growth over a couple of years. They spent 50% less time remediating security issues, and they were more than twice as likely to be recommended as a great place to work by their colleagues, by their employees. Those are huge. Those are real, measurable numbers, and those numbers can be the difference between a successful company and one that fails. So how do we get there? We know it's valuable. We know there's things we want to do, but how do we get there? I promise you there's a car analogy built into here somewhere. But what we're going to do today is learn how to build the roadmap. How do we get from wherever we are, no matter what stage of maturity your process is in, and how do we go where we want to go? How do we decide where we want to go? There's different endpoints that are going to be appropriate for every company. Not every company is going to want to have every single commit from a developer go instantly into production. There's going to be reasons for that. So we're going to figure out where you are, honestly and truly, where you want to go, honestly and truly, and how do you figure out the path to get there. And how we build the path to get there is we're going to build a road in between 4 main pillars of concern. We're going to worry about our source control practices. We're going to worry about our quality. What are our quality practices? Both automated, manual, anything to do with testing. What are our deployment practices? How do we actually get code out the door? And then what are our monitoring practices? Monitoring is our backstop, right? It's the backstop of what we didn't test, what we didn't think was going to happen. It lets us know that everything is actually okay. And without appropriate investment in all 4 of these areas, any continuous delivery attempt is most likely doomed to fail. And so what do we mean by that? what are our source control practices? So we're going to talk about the levels of each of these practices. And so you can figure out where you are. So at the first level, maybe you have a source control system. Probably, maybe. People probably kind of use it, but nobody really understands it. Maybe it's actually a hindrance to your work instead of a help. But it's not, it's not great. So at the second level, which many companies are at, you use a source control system, but you don't use it really well. You may have way too many branches. You may have too few branches. You may have branches that live for weeks and weeks and weeks, and then integrating them is a big pain. You may make every developer work directly off the development branch, and then they've got crazy merge problems every time they try to do everything. Code reviews might be a problem. But it's still better than not really having a system at all. You may be using GitHub Flow. And this was something that was very interesting to me, because I assumed GitHub Flow was the be-all, end-all, that was the best you could do. I've been using GitHub Flow for years. GitHub Flow is feature branches, for those who aren't familiar with the term. But it turns out, based on data from the Accelerate book, that GitHub Flow was actually not correlated with the best possible outcomes. The best possible outcomes for source control practices came from organizations that practice main trunk line development. And what main trunk line development means is you have frequent, sometimes daily commits to master for everybody. It means branches generally don't live more than a day or two. Changes are quite small. In GitHub Flow, it tends to encourage changes that are maybe 100, 200 lines of code. They're usually right on the edge of reviewability, realistically. They're a little more complex. They tend to touch a lot of different areas. Maybe you've crossed a couple API boundaries. And it encourages that. It makes that easy. In main trunk line development, what would be 4 or 5 commits to a feature branch would each be commits to a master branch. They'd be on your own branch. You'd put a PR request for each part. The key part being it encourages each part to go separately, which means each part has to stand alone, has to be tested alone, has to deploy, could theoretically deploy alone. So let's talk about our quality practices. So before I was here at mParticle, I was at a previous startup. And this previous startup was quite small. I was engineer number 3. But the interesting thing is, despite being quite small, it had a huge code base because it had been spun out of a much larger company, and they had taken this piece of system that was internal and made it customer-facing. And so my first week on the job, what I like to do is run the tests. I was at one point an SDET in my career. I have a long and detailed test history. And so the first thing I do to learn the code base is I run the tests. So I went to run the tests, and there were 45 of them, maybe 50. About 24 passed, and they were definitely not running at all on the Jenkins box. And so I went to my lead and said, is this it? Am I missing something? He said, no, it's probably fine. They do all pass on my box. So usually I just run them here, and then I'll build the deployment, and we'll just copy it up to Jenkins, and Jenkins will push it out. And I said, oh, man. And so we had a big release coming up, and that release went about as well as you could imagine it did. So the whole engineering team had been very busy all week working on this code. And release day came, and it started at 8 o'clock in the morning, and it ended at 8 o'clock at night, only because everybody was really tired and needed to start sleeping in shifts. Code went out, rolled back, changes were made, went out, rolled back, went out, rolled back. Didn't go well. We hadn't actually finished all the bugs and the problems in this big release for maybe a week. Engineers pulled huge hours, it was a mess. And so the next thing I did after that release is I said, let me help. We can fix this. And so we started paying special attention to our quality practices. We had pretty good deployment practices. We all used Git pretty well. We had some monitoring in place. It was fine, but our quality practices were quite bad. And so we spent the next year really investing strongly in our automated testing. Extensive unit tests, really good code coverage, some pretty clever integration test framework. And within a year later of it, focusing on our quality practices and really bringing that bar up, we were on true continuous deployment. Developers made changes all the time. They always went into production, and we never had a repeat of that first awful deployment. Your quality practices, which I know I'm probably speaking to a choir here, but your quality practices are key. So we started at level 1. We didn't have very many tests, very few automated tests, and the phrase, "it works on my machine," was endemic. It's the worst phrase. We moved to level 2. So we started at least running the unit tests. And when you start running the unit test automatically, a cool thing happens. If they're flaky, they get fixed. Because nobody wants to have their code interrupted by somebody else's broken, junky test. So because we ran them automatically, we made it a gate, all of a sudden the unit test quality went up in addition to the quantity. The test suites have to be reliable. An unreliable test is worse than no tests at all. Because the unreliable test not only isn't really testing what you think it is, but it's training everybody to ignore test failures. I have a number of times, and I get sometimes a lot of pushback about this, but I will turn off a flaky test. I will turn off a flaky test suite. I will turn it off. If it's not at least 99.9% reliable, it's gone. It's doing you more harm than good. So then we moved on to the next level. We started tracking our code coverage. And so some people feel very strongly about code coverage. I love code coverage with an asterisk of, I think code coverage above 80% is a waste of everybody's time. Unless you have regulatory reasons for it, you're starting to test ridiculous things like a setter. Where you start going down a rabbit hole of testing for test's sake. But you have to have at least a baseline level of code coverage to be confident in what you're testing. All your integration tests at this point should be automated. You may have some specialty tests, performance tests, UI tests. They probably run manually, and that's okay. There's still room for manual testing in a continuous delivery system, and we'll talk about where that goes. Still room for it. Manual testing is still important. And then by the time you're at level 4, pretty much everything should be automated minus some specific scenario test runs. You should have full automated everything because you don't, by the time your code is merged, you don't have time to start poking around at it on a dev environment. And we'll talk about how that works in just a second. So when I say dev environment, sometimes people go, ugh, dev environments can be a problem. But dev environments aren't a problem if you're containerized or if you're able to build up components specifically from one piece of code. So your deployment practices that matter. So if you're at your baseline level, right, you have builds that kind of work. You build them from wherever, sometimes from a developer's machine. Sometimes that's not great, but you don't have a lot of traceability, you don't have a lot of repeatability, you probably can't roll back. You got problems. So at level 2, right, at the next basic level, at least you're running them from your CI environment, from Jenkins, from TeamCity. You at least can have a predictable build, and you always deploy from this predictable place. You can probably roll back at this point, because if you're building a build from a predictable place, it's easy to get, build n-1. And then if we move on to the next level, not just do you create your builds from an automated environment, but you're able to build your components separately. Right? You can deploy, say you have 30 services, you can deploy one service, test it, and stand it out without having to deploy the whole system. It's much faster, it's much safer. You make much smaller changes at a time. Small incremental changes are your friend. That's sort of a guiding principle of everything, is small incremental changes are always better than large ones. Always. They're much more testable, they're more digestible, you're much more likely to catch an issue, and in a much quicker time as well. And so the last level is containers, containerizing your component build. Containers unlock a very interesting scenario, actually a couple interesting ones, but my most favorite scenario is the test environment scenario. There's a really good virtuous synergy in between containerization as a deployment practice and being able to actually test your code in a realistic and production-like environment. Because if you think about it, a container is just a combination of OS, a build image, whatever your build binaries are, and then your code from your deployment system. It makes no difference where you run it, whether you're orchestrating it out into your production environment, or you copy down a container and run it locally, or you spin it up on demand to run a dev environment as a part of, PR testing or as a part of candidate change testing. So being able to have those containers, that infrastructure as code, makes a huge difference in your ability to have confidence in a change, to get it out, to roll it back, and to say, yes, this change that I just tested is very representative of what it's actually going to look like in production. And so finally, we have our monitoring practices. And this is something that a lot of companies neglect. They spend a lot of time working on their test coverage. They may spend a lot of money on their source control system. And everybody kind of knows you need to maintain your CI Jenkins box or your TeamCity box or whatever. But a lot of companies neglect their monitoring practice. Without good, solid monitoring, which sometimes people call observability, I've heard it called a couple different things. But without this monitoring, you don't actually know what's happening. You think you know what's happening, but you don't actually know what's happening to your systems in production when they're out and running. And without knowing what's actually happening, you can't make intelligent decisions about what to do next. And so sort of the baseline level of monitoring is logs. Simple logs, they exist on a server, but if you want to go look at them, you probably have to SSH into the box, scan through the log, maybe do a grep. You can't do that at scale. You can't do that quickly. You can't do it automatically. Level 2 is a centralized searchable log store. There's a company here called Sumo Logic who provides that. Like, that's very important, being able to search through all of your machines, look for log trends. You can set some alerts on it. But it's got a key problem, and that key problem is speed. Those log systems, especially if you don't have highly structured, JSON-style logs, they lag. They can be quite far behind, maybe 5, 10 minutes. 5, 10 minutes may not sound like much, but in an online service, it's death. If we think about 99.9% availability and what that means, you get 8 hours of downtime a year. If it routinely takes you 10 or 15 minutes to discover a problem, you're going to chew through that 8 hours a year within the first 2 months. And so the next thing we move on to is metrics. Metrics, sometimes it's called counters, but metrics are much closer to real time and a better aggregation of data as a whole. Logs are great for finding specific instances of things that happened. When I know I know my server returned a 500 error, a log is great for telling me why. But when I have a whole bunch of 500 errors, you need metrics to tell you that. You need counters, you need a graph, you need an alert set on graph quantities, on a rolling average over 2 minutes or 5 minutes or whatever window you have. So having some metrics, having some basic metrics, even if you don't have a strategy, that's level 3. And then sort of the holy grail, the key of it is having structured logs, having standardized metrics, being able to build graphs and alerts programmatically because your metrics on service A and B are the same as your metrics on service Y and Z. They all look the same. They all monitor the same. They all have very similar limits. And you can get a really good idea for what's happening at any service at any point in time without anybody having to actually look. The system will tell you when it's got a problem. And so finally, we have the stages of our continuous delivery system. And so what does this look like? So the earliest stage is very manual, right? It's what I was talking about at the beginning of our journey when we, somebody sort of kind of builds a build and we kind of push it out and we hope for the best. We cross our fingers. We think, maybe this is going to be great. I don't know. Stage 1. So stage 2, early automation. Hopefully, a lot of us at the start of our journey with old code bases are going to be somewhere between stage 1, maybe stage 2. We've got some tests, maybe. We've got, a CI machine. But most we do our deployments, very manually, and we don't really have a ton of great monitoring. So stage 3 is significant automation. This is where our push-button deployments are. This is, a great end goal for a lot of companies. So your builds are automated. They may be, may or may not be containerized, but you can deploy with, a push button and maybe some scripts. It's pretty automated to get your code out there. And then sort of the final stage, the holy grail that lots of people say they're going to get to, most of us won't, and we don't all have to, is fully automated deployment. Where your builds are automated, your staging is automated, your deployments go out automated, they roll back automated. You have to be able, to roll back. But this is a lot of investment. But we could get there, right? We could get there. So how do we get there? First, you have to figure out where we are, right? This is the roadmap I was talking about. So the most important thing you should do first is do an honest self-assessment of where your organization is at across those 4 quality pillars, or the four pillars, and be honest about where you are. Right? This is not the time to try to say, well, next week or next month, or when we just finish this one thing, we're definitely going to move quality, from level 1 to level 2. Be honest about where you are right now with no additional dev work to figure out where it is you need to go. Most orgs are not going to be straight across the line, so a lot of them are going to be, let's see if this is working. Yeah, so a lot of them are going to be, pretty T-shaped. Maybe they're going to be a 3 at source control, a 2 for code quality, but they might be a 1 for deployment and a 1 for monitoring. Be honest about that, because by being honest with that, it's going to help you figure out where it is you need to go next. So how we're going to build this roadmap is we're going to figure out where we are and where are we deficient. Where do we need to be spending our effort next? Right? If you're at a 3 in source control, right, using GitHub Flow, you guys are pretty slick, but you're at a 1 for deployment practices, the place to put your effort is not moving a source control from a 3 to a 4. The place to put your effort is bettering your deployment practices. Move your deployment practices from 1 to a 2. Make sure you can do automated builds. You're going to get much better bang for your buck moving that, moving the earlier stages down to try to bring yourself to an even level. A really good goal for any organization is to keep your practices at roughly even level. So if you're, in a mixed state, you're going to have a false sense of security about what sort of delivery stage is appropriate for your organization. It's not appropriate for your organization, for example, if you need at least, let's say you need at least 12 points to do a semi-automatic delivery. If you've got a 4 in trunk line development and you've got a 4 in deployment, but you're a 1 in monitoring, you're not going to have enough numbers, and you know exactly where you need to go to get them. And so the next thing to figure out is where you want to go. We know where we are, we know what our practices are. Now we need to figure out where we're going to go. And as I said before, it's not appropriate or necessary for every single organization to have continuous deployment. It's not necessary, right? Maybe what's the standard in your industry? If you're in the medical device field, I'm certain the standard is not continuous deployment. You've got regulatory blockers. Do you have regulatory blockers in your field? Do you have any external issues, right? Do you have any customer-facing problems? Do you have contracts with the customer saying you have to have certain practices in place? Some customers, especially when you're a SaaS, are uncomfortable with the idea of continuous deployment. Whether that's good or not isn't right. It's not up for discussion. The customer, you signed a contract. Do you have internal blockers? Do you have an executive team that's just not okay with it, that they need more time, they need more comfort in the system you have before they're ready to take the next step? These are all important considerations, and they're not to be underestimated. Right? These are all stakeholders in your product, and their opinions count. Any one of these putting up a no, you say, no, you can't deploy continuously, or no, you can't even have build, push-button candidates. Any one of those needs to be addressed and handled before you, as a process of building your roadmap. And so, once you know where you are, and you know where you want to go, it's time to plot your map. And here's the car analogy I promised you. So you have to know, do we have enough fuel in the tank? Do we have the drive and the hours and the commitment to get there? Do we have the necessary licensing and authorization? Do we have buy-in from our stakeholders? Do we know that we've got permission from management? Management is going to support the whole initiative and not the first 5 minutes of the initiative and bail on it as soon as it gets hard? Do we have the correct engine size? Right? Do we have the knowledge and the engineering chops to make it happen? It's great to say we need to make our monitoring practices better, but if nobody knows anything about monitoring and nobody has any experience monitoring a production service at scale, you're not going to have a very successful couple of iterations. If people have to build the knowledge, you're not going to just go straight to, yep, we monitor everything perfectly, we know everything that's happening in production, we know if a butterfly flaps its wings in China. You've got to build your plan appropriate to the team that you have, appropriate to the resources you have available. Finally, do we have 4 tires, and are they all the same size? Right? If you've got a mismatched set of capabilities per level, you're going to have a real hard time driving and executing across your path. Right? You're going to have a lot of questions about, well, but our tests are really well automated, and we've got really good, we're containerized. Why can't we just deploy continuously? Well, you don't have any monitoring in place. Right? You're going to have a lot of friction and difficulty moving forward if everybody's not aligned all together. And so finally, some key takeaways here, some things to keep in mind. Capabilities beget behavior. If you make the right thing easy to do, people will be more likely to do the right thing. Don't try to dictate a behavioral change until you've got the capabilities and you've got the tooling to support it. Be honest with yourself about the amount of resources and investment your team can make. If you're trying to also ship production features, you probably can't dedicate 100% of your entire engineering team for 6 months to improve all your deployment practices. You're not going to get buy-in from management. You're not going to be able to run a company that way. Be reasonable and be very honest with yourself and honest with your management about exactly how much effort per release or per iteration or per however it is you're tracking, how much you can invest into it. Know your quality pillars. And again, be honest with yourself about where you are on them. Make sure that your team is staying balanced across all 4 pillars as you iterate. Make sure you're not wasting effort when you could have some low-hanging fruit or higher wins. And finally, just make sure that everybody's aligned. Make sure that everybody knows where we're all wanting to go and we're all driving there together. Thank you.
If you've got a question, please
Yeah.
raise your hand and I will bring the mic to you.
As part of the fully automated flow, like continuous deployment, so the change order also is automated, like in your process, or it's something, because whenever we want to push the code to the production, the change order needs to be created and all, right? That process is also automated. And also, if there are any failures in the build, like test failures, who is approving that? Like whether the code will be reverted back, and after the deployment, what kind of post-production deployment monitoring is happening as part of this continuous delivery?
Okay, so there were a couple questions in there. The first one is what happens when a build breaks? And when a build breaks, it stops. It doesn't go any further. So ideally, we want to catch that stuff really early. And so part of having a more mature, capable system is being able to, for example, pull up a dev environment and run automated tests off a pull request rather than off a commit merged into the master branch. And so a lot of the issues, and we find this again over and over in our teams, get caught at pull request time before any change lands, right? Because you want to waste as few people's time as possible. I'd rather waste a developer's time than waste an entire team's time, especially if it's the developer's fault that they wrote a bug. So ideally, you run all your tests, you run everything at pull request time. You don't allow a merge into master until you're pretty sure it's going to pass the quality bars. We do a lot of our manual testing as well at pull request time because we can spin up environments on demand. And so we'll do any scenario-based, any exploratory testing, as well as any automated testing at the pull request time. Once that commit merges into master, I won't say it never breaks, but it breaks very infrequently. Maybe every 1,000 commits to master, we'll have somebody make usually a bad merge. Usually somebody has to resolve a merge conflict and they make a mistake. At that point, again, it stops. The people who are responsible for the break, because your source control system will tell you who it is, are responsible for fixing it, or responsible to triaging to somebody who can. And then your secondary question was about monitoring in production? Post-production.
Like, what kind of validation is happening after the deployment? Pushing the code to production, or you do any validation or any monitoring of how the servers, the health of the servers are monitored? Or?
Yes, so after you push a service into production, I like to run the tests on it one more time, whatever functional end-to-end integration test you have. if a problem makes it out, that means it's past your whole test suite. And so the backstop for the testing, the testing that we didn't do is monitoring. And so that's, what the whole monitoring pillar is about is wiring encounters that tell you your service is available, whether you're using live traffic or synthetic traffic. It doesn't make a huge difference exactly, except for your risk tolerance. But monitoring what are the, what are my HTTP status codes? What are my per service level counters? What are my per feature level counters? And then setting, you want to set thresholds on those. Say, I can't have any more than 10% failure on this counter over a 5-minute window. And it's very similar to, it's the same concept as an automated test, but it's sort of a monitoring test, if that makes sense. Is that sort of, sorry, it's very, very bright. Does that sort of answer your question? Okay. Looks like we're running for one over here.
Hi, I just had a quick question on that. So we're moving towards testing on the PR, so before code is integrated. I'm curious around the timeline. Like when you say run your whole test suite, I'm just curious, like how long does that actually take you guys to complete before code's integrated?
So we run a lot of tests, but we run them separately and we run them staged. So build and unit test, ours takes about 5 minutes. That runs immediately. And then if your build and unit test pass, we move to the next stage. And the next stage may take 20 minutes, may take half an hour. Standing up an environment, a containerized environment takes maybe 5 or 10 minutes, and then running integration UI tests on it may take another 5 or 10 minutes. And then we have optional stuff. So the way we've worked in our build is that we have some tests that are not appropriate for every change or every stage in the change. And so we may have some that we only run when we're really for sure ready to land a change. So we run our test of least impact first. Or rather, actually, our fastest test first and our most critical test first. And though the tests of least impact get run last or optionally, because it's up to a developer and a tester's discretion about what a test suite covers and what a particular change needs. Developers have short patience. They're not going to wait too long for changes, for tests, especially on a PR. So our goals are, we have pretty strong metrics around what is the acceptable time per stage in a test to take when it's running, when it's blocking a PR and it's blocking a developer's productivity time.
You mentioned moving from Git flow to trunk line. Are you using any techniques to manage the release of an epic or a saga?
So it's an interesting question. So managing the release of an epic or a saga, the way it works, the way it's worked for us anyways, is the pieces for it go out, maybe feature flagged or maybe just disabled or maybe they're just not called, they're harmless. And so pieces will go out over days or weeks or months depending on how long an epic is taking. They'll go out, some of them will be able to be validated in production, some can't because they're inaccessible due to missing code. So they'll go out, pieces will go out, pieces will go out, pieces will go out, and then the last commit is the one that turns it on. It may not be very deep, it may not have a lot of crazy, important, excellent, hard to understand code, but the last commit turns it on. So that includes, that last commit has usually very little code time and a lot of test time. Doing scenario validation, doing whatever end-to-end extra testing is appropriate.
Thanks.
I think we're almost out of time, maybe? Time for one more?
Hi, I've got one question regarding trunk development as well. So I know it can be very fragile, especially if you get teams with 200 developers. I'm wondering how did you manage that piece? Because we're working with the Git flow. I would like to be within trunk development, but I know it can be very fragile and create a lot of errors down the line.
So when you're in trunk line development, you usually need what's called like a submit server, especially when you're making lots of commits. And the submit server just basically combines a bunch of commits together, builds them, runs all the quality gates against them as if they were a PR, and then kicks them all out. So it may aggregate 5 commits together, test them all together, send them out, and if that fails, it just boots the commits out and lets other people's commits go until people can resubmit their commits when it works.
So is that based on multiple repositories, or is it just one? Meaning, if you have like 50 microservices together living with, let's say, 3 monolith code bases, does that work all together as well?
No, so the submit server would be per repository, to get around the problem of people making hundreds of commits and inevitable merge conflicts, and the smaller and more potential for smaller issues that happen with the smaller merges. So to test across a microservices stack, where you may have a bunch of different branches coming together, is where, you can run into issues, but more likely it's keeping your test run as fresh as possible, right? Making sure that your microservices are deploying somewhere testable as quickly as possible and keeping your test run as fresh as possible to limit the amount of time that issues and errors could creep in that could make your test run stale.
Okay.
So, basically that will invalidate a test run after a certain amount of time or a certain number of commits, and you'll have to do it again.
All right, thank you.
Anybody else? I can't see anything, so I'm definitely relying on other people. We're good? I think we're good. All right. Thank you guys very much.